screen will look a little different now. But as I said before, this HyperWorks Desktop 2021, you have to open, it has to have some kind of blue icon in front, but which looks more like this red one, but in blue. So blue is the indicator. And it takes some time to open the tool.
Sorry.
Sure.
I tried to open the program and some license error occurred to my computer. Do you know how to fix it?
Yeah. Did it work before?
No, I'm just opened it the first time. I don't know.
Yeah, but it's on your own computer. Yes, you're in Germany, right? So it's your computer.
Yes.
Yeah,
I downloaded it yesterday, but I didn't start it.
Yeah, you should have started it. You probably have to copy some license files somewhere. I never installed the student edition, so I was hoping that all of you tried before and finished or did it before.
Okay.
I'm not sure what they gave. Did they send you some license file? Do you know that? Could you download?
Yes, I had the license file and I also directed the path, I think, but it's not working somehow.
Okay, well, no, usually I have to check the path is somewhere. Yeah, it should be somewhere Altair. And yeah, it's different with yours, but there was some, no, it's programs, right? It must be somewhere under programs, I think. Let me check. Why is it? Where are my programs? Sorry. Program files, where is Altair? Altair. Well, problem links. So because I can just put it down here, but yeah, it's a license server. I'm not sure if you had to install the license server as well, or is it just the license file?
Like I downloaded the license file.
Because what I have to do every year, I get a new license file and I have to copy it in the same folder and have to make sure that the file name is correct. So it's Altair_lic in my case, but it's probably a little different on your computer. So, but then, well, I will show a little bit today for the first half hour. I think we will continue tomorrow. So try to figure out how to do it during the night, so to say, and then hopefully it works tomorrow.
Yeah, okay.
For all the others, does it work on your computers or do you have the same problems? Anyone with problems? No problems. Okay. Okay, maybe we can later after the session ended, if you still have time, we can take a look at your computer. Maybe we can fix it somehow together. Mr. Badura. Okay. So, but all others should see something like this. So there's some user profile interface and you should select OptiStruct here. And then the program knows how to design the different graphical user interfaces inside the tool. And now you see the screen. It's the main part, the gray part. That's the part where you later on will see the model you're creating. And you will see you can easily move and rotate the parts. In the upper part, you see the different tabs, and it's organized in a way that you start on the left-hand side and then work from the left-hand side to the right-hand side to build up your model. Don't be afraid, we only use some of them, not too many of them. It's a big tool, but we only use some of them. And for example, you can work with the geometry and do some things, then you can start the meshing, then you can define materials, then you can define properties, then you can define boundary conditions, and somewhere with tools, you create the load case, and then it's analysis, you can do the simulation run. And most of the commands you find in these drop-down menus up here, you also find down here in the lower right-hand corner. That's the old version of HyperWorks, but that's the one I'm really used to. So you see again, similar design or commands related to geometry work. Then it's 1D meshing, 2D meshing, 3D meshing. It's calculation. It's some special tools and some post-processing, which we don't need in this case. So it's a very similar structure. And you see some commands up here. I think it's best if we just import our geometry, and it says in exercise 0, import the geometry. I hope you copied it somewhere so you can open it from there. It's a geometry file. It's an IGES file. So we say file, import, and then it offers us different options. We are interested in importing a geometry. I click on it. And in my case, it's set to IGES, but I think it's just because I already used IGES before. So if it's not IGES with you, then change the file type to IGES. And with this folder tab, you can go to the folder where this file is, where you copied it, and exercises for students. It's exercise_0.IGES. And then you say open, but even though you said open, it didn't open it. It just put it into the intermediate list. So you have to import it in the next step. And then you should see the part.
Excuse me?
Yes, sure.
Can you repeat again? I have missed it currently on my program. I just have two bar is sessions, mask, and model. They don't have the import.
Yes, but did you do file import?
Oh no.
File, the file tab, and then import, right? And then geometry. And then this tab should open, and then you can go via this yellow icon to the folder where you find your exercise file.
So I should download it from somewhere, isn't it?
I think Tuomo provided the data in Moodle, right?
Yeah.
So you should have copied it somewhere on your computer, so you can open it from there. It's difficult if you can't really see what happens at the other computers, but I hope most of you have this geometry file in their screen now. And now it's about using the mouse and the control button. In German, it's the Steuerung-Knopf, control button. So pushing the control button and using the left mouse button rotates the part. Using the control button and the center button, okay, you can create this to zoom, and using the control button and the right mouse button, that's more important, you can translate it. There are other options. You can use also the bar up here to start to move. You can go to the hand and then you can move it. You can go to the rotate thing and then you can rotate it in some directions. But I like to use the left and the right mouse button. Left mouse button to rotate, right mouse button to translate, always together in combination with the control button on your keyboard. So you can rotate your part and move it a little bit. And with the wheel, you can also with the control button again, zoom in and zoom out, make it smaller, make it bigger.
Excuse me?
Sure.
Yes. I think I don't know how to download the file on the Moodles. When I opened the the Moodles and I press in exercise. Normally they have to download, but in there they show up kind of the code only.
Yes, I have the same problem too.
Okay. Okay. Miss, too bad that I'm not there. So it's usually, doesn't it say that it saves it somewhere if you, okay, because, but if you press it, doesn't it save automatically to your documents folder, your download folder on the computer?
No.
No.
No, they just open a kind of text
Or
like that. I think it is.
Yep. But then save this file somewhere on your screen or whatever, somewhere. Save it somewhere, and then try to open it from HyperWorks.
I don't know how to save. Like the. Can I share my screen so you know the?
Yeah. Yes, you can. Okay.
Yes. Is Moodles, and when I press it, it's like this.
Yes.
And
Okay. Then you can you save it? Save as. It was save as there. Go again. Save as. Fourth from top there, and then save it to some folder where you were working at the moment. Yeah, or desktop. But yeah, and then you have to delete the txt extension. It adds an extension. Yeah. Okay. Can you go where you saved this file? Which folder was it? Was it the desktop?
Yes. Wait. Actually, I have to do it in the school computer, but I can only open the Zoom on my own computer because in the computer.
Oh yeah, it's working now. Like when you save that and like you save something in some folders, and when you import that, and it will work. Like for me, it's working now.
Okay.
I did what you told, so it's working for me.
Okay. Very good.
I will try it.
Yes, sorry. It was to expect that there's some problem, but we'll manage. So, but yeah. Nevertheless, I think I will continue. Any other problems from other persons, or did most of you manage to open this file so far? Okay. So the meshing part happens under the model tab. So here you can see, you can click on these small buttons here, then everything opens. You see this model consists of 2 components at the moment. It doesn't matter, one part, one title. That's really not important.
Excuse me?
Sure.
I think you didn't share.
Oh,
this.
yeah, you're right. I didn't share because, yeah. Thanks. Yep. And there. So I went from the import tab to the model tab. So you see different things you can expand here if you want to, but that's still just geometry.
Excuse me, sir. Like if you don't mind, can you record this session like now? So we can look later and do if we miss something.
Sorry, what
like can you record this session?
Record, yeah, okay, oh, yeah, yes, I can. I hope I have enough space. My computer is quite full, but I can. Yeah, it's a good idea, right? But then I have to provide it somewhat, but I will manage. Okay, just a second.
Recording in progress.
Okay, so now for you to be able to follow or look at it later, this is the part. I went to the model tab. So far it's just geometry. You see here, this blue part is the geometry inside the component. I can activate or deactivate it with the left mouse button. And here there will be the finite element stuff in there, but there is no finite element stuff for this component defined so far. So we only have one geometry part. And the easiest way to create a mesh without thinking about it before is just pushing the F12 button. Sorry, it's my computer here. The F12 button. If you do so, something opens down here. And it offers you the option to select surfaces, geometrical surfaces, and create a mesh. I predefined 3 millimeters as element edge length. You probably have to change it by hand because you probably have 10 millimeters. And I said, okay, I like quads, not triangular elements. I want to have quads. This is something I changed. Everything else I would keep the same. And then you can, this is always a selection window, this yellow window with a light blue boundary around it. If you click on it, there is some further selection. If you move too fast, this goes away. But if you move slowly, you can go to, for example, displayed. So you want to select all the surfaces that are currently visible, and then they turn white. Then you know, okay, you selected the surface and you want to put a 2D mesh on the surface using elements with an average edge length of 3 millimeters and with elements mainly as quad elements. So 4 node elements, the beta elements, as you've learned before. And then you can say mesh. And then it offers you some meshing. You see some numbers here because it gives you the possibility to modify some things. So it tries to add elements with an edge length of 3 millimeters, but you see it doesn't work everywhere in the same way. And you can modify some things. I won't do this now. I just say return. With return, I accept what it offers me. And then I have a meshed part. So meshing is very simple. It can be very simple. You will learn later that, as I said before, it makes sense to think about the meshing before to have life easier later on. But if you just want to create a mesh, it's quite simple to do this. And what I like to do is push this button here to color in the meshed part. And then I can take away on the left-hand side the geometry. You see, this is the geometry which is still visible. Now only the mesh is visible. And you see here, it has some nice elements, quite nice elements around the holes. It looks okay. There are some parts that do not look too okay. You see here some triangular elements and the element shape is not so nice. And as I said before, sometimes it makes sense to do a little work in advance. And you see also here, this is with control and the wheel bar pushed, then I can create such a window. You see, this doesn't look nice. We should maybe prepare something in advance before we continue, but you see, in general, it's very fast to create a mesh. With return or with escape, you always jump back. So now we are on the upper slide here again, and I don't like the mesh. And there is the F2 command, which is the delete command. And then I can say, what do I want to delete? Not loads. I want to change from loads to elements. I do this on the arrow left to this file and say, I want to delete elements, all of them, because I don't like them. And I delete them. And I have to make the geometry visible again. So now the elements are gone again, because it makes sense to do some preliminary work, because what the meshing does, it takes into account all these lines. So it tries to add nodes on all these lines. And you see here, some of these lines are very close together. And if it tries to put nodes on all these lines, you get very small and very long elements, and the shape doesn't look nice. So it makes sense to prepare the model a little bit in advance. And I will do just one preparation. I will suppress some of these lines. We call it toggle, so that they will not be used for the meshing process. And that's the edge edit. So I want to change some things in the geometry. So I go to the geometry tab, and it's about doing something to the edges. So it's edge edit. And you should probably find it up here, geometry, edit, probably this. You see, I like to go down there. Does it have edge edit up there? Card edit. So no, let's go down here. So geometry edge edit. And then you see all green lines are, green indicates that these surfaces are connected to each other. That's okay, but all green lines are being taken into account for meshing. And here, I don't like all these. So I just use the left mouse button, only the mouse button, nothing else, to click on this line. It gets blue. And on this line, maybe you can see it. So now it's a little bit dashed and blue. And that means this is suppressed. It will not be taken into account for meshing. So I only have this middle line. And you can take a look at some of these. Here it's the same, so I can do the same. It's symmetrical, so we have it here again. And here it's also some lines. And here, that's what I meant by preparing the model. So suppressing some edges, you don't have to do it, and it will also run if you don't do it. But I like to have a nice starting geometry. And I think somewhere here and here, we can also suppress some things. And here also. And now you see when I go back to the main tab, escape always helps. If you want to jump out of these tabs, just push escape and then you jump back one level up, one level up. You see they are just dashed now, and only the full lines, the solid lines, will be taken into account for meshing. So this was the preparation process. I just meshed it. I saw, okay, it doesn't look too nice. So I did some preparation that was suppressing some edges, toggling them away with geometry edge edit. And now I can start to mesh it better. Let's first take a look at the exercise itself. So we want to put in constraints around these two holes, and we want to apply a force here. And there are different ways to apply forces. The best way is to put singular forces on the nodes. And in order to do this, it makes sense to have a certain number of nodes around this hole. And a good number is, for example, 20, because 20, you can easily divide 100 Newton by 20, then you know how much force to put on each of these nodes. So this is also something you can do in advance to have it easier afterwards when you put together your model. So let's do this. I want to mesh it. As I said before, I can do different things. I will just mesh it. So meshing, as I said, it can be F12, or you find the same under 2D. That's meshing and auto mesh. 2D for 2D elements. Auto mesh is the same than the function key F12. You've been here before. And now we can say we want to use all surfaces, 3 millimeters length, quad elements. I want to mesh them. But now I say, okay, I want to have 20 nodes around this hole, not 19. So I can use the left mouse button to click on the number, and then it increases it, 21, 22, or with the right mouse button, I go down again. And this is the way I can influence the meshing. And then I can mesh again, and then it takes into account these 20 elements, that is 20 nodes. And now I prepared this hole in a way that I can later on more easy put or apply my forces. All other holes I will keep the same. I could change them. You see some graphical problems with my graphical card, but it doesn't matter. And then if I say return, it accepts it. And now it looks better. You see here where we had these distorted elements before, because we did some preparation of the model, you see everything looks a lot nicer. So now we have geometry data and finite element data in the same component. I will leave it this way for the beginning. We can modify it later on, but it's not important. Now I think it's more important to set together our model. So we did some geometry preparation. We did the meshing. We need some material. I start here. I want to create a material. Then some user interface opens. I can give it a name. I call it steel. And most of the things are already there. MAT1 is a linear material. I can leave it this way. And here you see Young's modulus. It offers us 210,000. I'm using this unit system number 2, but you have to say return once, so it accepts it. And then for new, return once, and we don't need density now. So Young's modulus and Poisson's ratio. And then I have to define my material. Linear material with an Young's modulus as given here. And you see a new cupboard occurred with a steel material. If I click on it, I get information relevant to this material down here. So I can easily modify the entries afterwards without going through all the tree structure. I just have to click on the material. So now I have a material. I need a property. These 2D elements need to know how thick they are. Now they are just 2D, but it's a sheet metal part. So I have to define the thickness. I have to create a property. And I call it 2 millimeters, or let's say 2D, 2 millimeters. It's just any name. I should be able to see afterwards or understand what it means. Card image, property shell. That's perfect. I can already select from my cupboard with materials, which is the material that belongs to this property. I can do this by clicking twice, and then, okay, the steel material is what I want. And the only other value I have to define is the T. T stands for, I can go with the mouth there, thickness. So to return, and then nothing else has to be defined. We can define so much more, but we don't need it. Just say, okay, what's the name of this property? It has a card image for shell elements, and it has a thickness of 2. And I assigned already the material. You see here now another cupboard occurred with with properties, 2 millimeters. And you see here down here already, it knows already it's made out of steel. Perfect. All I need to do is this one doesn't, this is assignment of property and material to the part itself. So this part has no property. I can select from my list. There's only one part, and then it knows already, okay, this part which I meshed has a property of 2 millimeters and a material of steel. Now I have a meshed part. I have defined and assigned the property. I have defined and assigned the material. All I need now is to constrain the model and to apply load. And this can be done here by boundary condition. Boundary condition means everything, loads and constraints. I just do it. I create. Let's start with forces. I said we want to apply 100 newtons around one of these holes. So I want to apply forces around this hole. And one way to do this is by clicking on every node with the left mouse button. That's how I select the nodes. It takes a long time. Everything is very slow because of the zoom. I already finished the clicking, but it still needs some time to select everything. There are better ways, but for the beginning, it's just okay to select the nodes where you want to apply forces, click with the left mouse button. Okay, there it is. Then it was, okay, 100 newtons, 20 nodes. So it's 5 newtons per node. Then we have in total 100 newtons. And it was in Z direction. It was a negative Z direction, so I can add a minus. It's difficult to see here because you see the Z direction is the direction perpendicular to the sheet metal part around the hole, and its force in opposite Z direction, it's negative. It's a force. This is just for display purposes. And then I say create. No, did it do it? Yeah, now it did do it. And then you see some forces. And it says 5. No unit, because you need to know, I need to know which is the unit system I'm using, and I'm using Newton and millimeters. So it's Newton in this case. And you see what happened. A load collector occurred. They called it auto. Yeah, it's because every force, every constraint is put to a certain load collector. You can easily rename it. If auto 1 doesn't, you don't like it, you just push the right mouse button on the name and say rename, and you call it load, for example. It helps you if you have a bigger model to see the different parts and understand their names. You can also use the left mouse click to change the colors. If you don't like the color of the force arrows, you can easily change every color you want, also for the parts if you want to. Something is a little slow here. My computer is a little stuck. Didn't want to change it. Okay, doesn't matter. So now I already have loads applied. And now I only need to constrain the model around these 2 holes. And constrain is also creating a load. So why does it do it like this? Come on. And if I now create another load or constraint, it will automatically put it to the active load collector. Why is there a plus sign all the time? I don't know. So I create a new one here, calling constraint. And you see it gets bold, and bold means it's active. So every new constraint I apply is put into this cupboard drawer. And create, come on, some constraints. And then I can again say, okay, I want to constrain these nodes. Click at them, it takes some time again. So I selected the nodes, and with this I say which directions shall be constrained. DOF 1, 2, 3 is X, Y, Z direction translation, and 4, 5, 6 is rotation about X, Y, Z axis. I want to constrain everything. We will talk about this later on. So the displacement will be 0 there. I create it. You see these arrows. I'm not sure why there are no numbers. Label constraints. Okay, here they are. And I can do the same here. So I select the nodes around the hole, left mouse button, click, 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 click. And create. You see 1, 2, 3, 4, 5, 6. So every node is constrained in all 6 directions, 3 translations, and 3 rotations. And now we have finished creating our model. So we have prepared the geometry, we have meshed the part, we have applied some loads, we have applied constraints, we have defined a material, we have to define a property, we have assigned both to the part, and now we can do the calculation. Is any one of you still with me, or are you just listening?
I'm missing from the step of creating mesh.
Okay, but yeah, but then you have the video. Hopefully, I will repeat it tomorrow morning again, think in a fast way for all of those who couldn't attend today because their tool was not working, but maybe the video also helps. Okay. Well, so now we only need a load case. So we have to define what we want to calculate. The easiest way to do this is to go to Tools and scroll down somewhere. In my window, it's not enough. There's a load step browser. And then here, with load steps and right mouse button, you can create a new load step. I call it whatever. Static load, that's my name. And then you can go through the tabs. It's not too much. You say you want to do a linear static analysis. So just a second from top. You don't need headers. You have to define some input. You have to say what's the load you want to use, and it offers you all the loads you have to define. And you have to tell the tool to really use this by pushing it or copying it to the other side. So this will be used as loading. It will use the load I have to define in the load cupboard. And we need constraint, SPC, single point constraint. It shall use this. And that's all we need. So saying static load, and then the load and the constraint copying to the other side. And then we can go back, and here you also see now the load step defined with the SPC and the load. Everything can be seen here. Nothing else has to be defined. And now I'm curious. Now we have to do the calculation. And the simplest way is to go to analysis and to OptiStruct. And then you can leave everything as it is, but maybe you can also change it. It doesn't change it, do everything, and analysis. I'm not sure if there are any differences. I usually leave the default, and then it saves it to a finite element file. So this is now, everything is done in HyperWorks. And as I said before, for OptiStruct, for the calculation, it needs a special format. This is automatically being created when you start the simulation. It has the extension FEM. And I say, okay, do this. And then it saves it. Some information is displayed in the left-hand corner of the window, export complete, ready, and so on. It's very small. And then some calculation window opens. Hopefully there is no error. No, there's no error. That's very good. It says analysis complete, no error messages, perfect. And you can immediately open the result. Hopefully this button is available when you do this, because sometimes this tool is buggy and the button is missing. And if we press on results, it automatically opens HyperView, the tool to look at the results. I have some graphical issues, but doesn't matter. Now you see here, it looks very similar to HyperMesh. There's the part, you can rotate it, you can translate it, and so on. But this is for looking at the results. And the colorful results you get when you look, when you press at the color button here. And then you can select, do you want to look at the displacements or at the stresses? Let's look at displacements first. Say apply, nothing else. And then you get colorful picture, and you see from the scaling here, blue means zero displacement. That's where we applied the constraints. And red means maximum displacement. That's where we applied the load. So it makes sense. You can also show the mesh here. When you push this and you see it a little better. See, this is the displacement. This is the magnitude of the displacement. Of course, you can also look in X, Y, Z direction. And you can look at the stress, which is also something you're interested. Von Mises is the equivalent stress we are usually looking at. And you see stress concentration is somewhere in the vicinity of the constraint. Around the hole, which we constrained, which is probably not so reliable because there's some constraint, but also in this curved part here, which makes sense because we apply the force at this free end and then it bends somewhere where the high stresses occur. Mr. Petrov wrote a message to me which said here. I'm not exactly sure what it is supposed to mean. Okay, nothing. You can do a lot more things, but that's the most important, to be able to load it, to move and rotate it, to look at the colorful plot and take a look at the numbers. You see here, red means 2.82 times 10 to the power of 2. So it's 282. With my unit system, Newton and millimeters, it's Newton per millimeter squared. So it's a stress. And the displacement, even though it doesn't say so, because of the unit system I used, 7.4 means millimeters, so it goes down by 7.4 millimeters. You can also animate this. You can move this animation button to the right and you see it moves downwards, or you can do this automatically. Then it moves automatically up and down. And this one is for the speed. I don't like so much speed. So down to see how everything deforms. And you can also, with this scaling button, do a display scaling, so you'll see a little bit more, just so you get an idea. And you can also apply an undeformed shape, so you see where it started. So you see there's a lot more you can do, but I think for today that's enough. I will somehow figure out with Tuomo how to upload the video, so you can take a look at it if you want to. I will stay here a little longer for Mr. Badura, if I got it right, for trying to fix his license issues. I hope that everything works properly with your tools tomorrow, with all the other tools. I recommend in preparation for your exam that you go through the content of today's lecture for like half an hour in the evening, just to look through it. What did I mention? What did I say was important and is important, so that you should have a good preparation for Friday for the exam. I hope you all will pass, but I also hope you all learn